Okay, so let's begin with trigonometric graphs, and we'll be discussing sine, cos, and tan. And our maximum extent, let us start with sine theta, graph of sine, and it would be a sine bx plus c, where a, b, and c are constants, and x is the angle variable. So if we draw sine theta or sine x, it would look like this. Maximum value would be 1, minimum would be -1, so ranges from -1 to 1, and the graph ends at 360. If we are doing this in radians, this would be 2 pi and equal division pi. This is pi by 2, and this is 3 by 2 pi. Again, maximum is 1 and minimum is -1. So what happens when we draw 2 sine theta? So basically we are attempting for a. A is the amplitude. So when we draw the graph of sine theta from 0 to 360, this would be 2, -2, and nothing else changes. This is 360, and we have the equal divisions 90, 270, and 180 as shown. So this is about amplitude. Basically, the general graph of a sine theta would be where a is positive. This is 360. Maximum value is a, minimum value is -a. So what happens when the value becomes negative? For example, when you have -3 sine theta, a quick rough sketch, sine theta would look like this. This is 1, this is -1, but 3 sine theta will have 3 and -3. But what happens when it is negative? The graph reflects in x-axis. All those values which were positive now become negative. All those which were negative now become positive. So the graph will reflect in x-axis. Maximum value still stays 3 and minimum -3, and it still ends at 360. This is 180, this is 90, and this is 270. Now let's try to draw on one graph. Let's say we have this grid and we draw sine theta. If I say this is 1, this would be -1, and it ends at 360. And we draw 2 sine theta on the same graph. Only the amplitude changes, all other things remain same. So it reaches at a maximum value of 2 and minimum value of -2. This point is 2 and this is -2. So after we're done with A, let us now discuss B. It was A sine bx plus c. Now when we are discussing B, let me eliminate A and C for now, and we'll bring them back in later. Now B is basically number of cycles in 360. For example, if I say sine x, there is one curve in 360. When we say sine 2x, there will be 2 complete cycles in 360. So sine theta appears like this. It ends at 360, starts at 0, maximum is 1, minimum is -1. And sine 2 theta, I can say that this is 180 because we have 2 curves, 2 complete cycles in 360, and this value stays 1 and this is -1. Now bringing back A into the picture, let's say we draw 2 sine 2 theta. This first 2 says, or let me make it 12 to avoid confusion, this 12 says that it is the amplitude. An examiner tells you to draw the graph from 0 to 180 degrees. So we already know we have 2 cycles in 360. So one cycle will be completed in 180. So when we draw one cycle, this point right here is 180, starting point is 0, this is 90, this maximum value is 12 and the minimum value is minus 12. Let's have a comparison on one grid. Let's say we draw sine theta. So this ends at 360. Highest point is 1, lowest point is minus 1. Then let us draw sine 2 theta. Now this should complete in 180. And we have two curves in 360. Trying to make a better curve. I think the previous one was better. It should go to a maximum height of 1 and lowest of -1. And when we draw sine 3 theta, we have 3 curves in 360. 1, 2 and 3, all at 1 and -1. Bringing in C, A sine bx plus C. Now C is basically the shift. It takes the graph upwards or downwards depending upon the sign. So if we have sine theta, the graph appears like this, ends at 360 between 1 and -1. But if I say sine theta plus 1, I should take this graph 1 unit up. So all the points, when you raise them by 1 unit, this is what you get. So this new graph is sine theta plus 1. It is always easy to move the axis, the x-axis, then moving the graph. For example, we had this graph of sine theta. This is 1, this is 0, this is -1, and I tell you to draw the graph of sine theta -1. Now taking this graph downwards is a little tough. If you draw this downwards is a little tough, then actually moving this x-axis upwards. So if I just move the x-axis upwards, you can see that we still have the same labels, and we can remove this x-axis, and obviously when it was 0, 0, -1, you can change these. So this is sine theta -1. Now if we have a graph of 2 sine 3 theta plus 1, and the question says draw the graph from 0 to 120. As it is already 3 theta, we know that 360 by 3 is 120. So the cycle should complete in 120 degrees, and it is having an amplitude of 2 and plus 1. So I'm basically not mentioning any number on x-axis or y-axis. So just imagine that this is the line, this horizontal line. Just imagine. Do not draw it, and just imagine. So if we have sine theta, and because this is plus 1, this should have started from 0, and plus 1 makes it 1. This should have been -1, plus 1 makes it 0. And this is 2. And if we take care of this amplitude, we know that amplitude should have been plus 2 minus 2. Graph should be between plus 2 and minus 2. So only the amplitudes 2 and minus 2. So when you raise this by 1 unit, all the values actually go up by 1 unit, or we just bring this line down. And I start from 0. This is 1, this is 2, this is 3, this is minus 1. So graph will look like this. Then we have a question which says that state the range. For this particular question, I can say that the range is from 3 to minus 1. So let's say this is a function, and I can say this function ranges from minus 1 to 3. For instance, for sine theta, we knew that it was 1 and minus 1. So range of sine theta is minus 1 less than equal to sine theta is less than equal to 1. So for any graph, for example 7 sine theta, we know that it would be from plus 7 and minus 7. So range would be minus 7 less than equal to sine theta less than equal to positive 7. So what if the question is 17 sine theta plus 4? So we know it would have been 17 and minus 17. This plus 4 raises it by 4 units. So you just add 4 to them. 17 plus 4 is 21. Minus 17 plus 4 is negative 13. So we have the range from minus 13 to 21. Any confusion in cos theta, sine theta? Now all these things remain same for cos theta other than the shape. Shape of cos curve is like this. This is 360, 1 minus 1, 180. Everything else stays same. So I'm quickly drawing it. Let's say cos 2 theta. So we have two curves in 360, or I can just draw it till 180 and it is still cos 2 theta. So if I touch the amplitude 3 cos theta, this is the curve, ends at 360. Now this is 3, this is minus 3. If I write 3 cos of 2 theta and I am drawing one cycle, 2 theta means there are two curves in 360, so 180 makes one curve. This is 3, this is minus 3. And same goes with 3 cos theta plus 1. So I have to raise it by 1 unit. I'm just sketching the curve. I knew that I would have started from 0 and this highest point would have been 3. But because of this plus 1, this is now 4. This lowest point should have been minus 3. But because of this plus 1, this is minus 2. And this now becomes 0 and it ends at 360. So A, B and C for cos. Now let's try for tan theta. Before we draw the graph of tan theta, it is advised to make these 4 equal divisions and draw an imaginary line. It is not compulsory to draw, but it's better if you mark it. These are known as asymptotes. Graph will not touch this line. It comes here and raises, and it never touches this vertical line. This is 360 and we do not have anything on y-axis. So graph of tan theta, if I say this is graph of tan theta, that's true. If I say this is graph of 2 tan theta, that is again true. If I say this is graph of 713 tan theta, that's again true. So the amplitude in case of tan makes no difference. And for tan theta, let's say we introduce a number 3. So this should now contain these type of curves in 120, because in 360 there are 3 times, it makes 120. So what we do is we just draw these 4 points and an asymptote at second and third. We just draw the curves, and because we knew that it is 3 theta, it should end at 120. This is 120 degrees, and then use your calculator to mark equal divisions, and that's it. So this is true for tan 3 theta, or if you say that this is 7 tan 3 theta, that is again true, because in case of tan, amplitude does not matter. Third thing, let's say we have tan theta, first vertical line, second vertical line ends at 360, and we draw graph of tan theta, and then the examiner tells you to draw it for tan theta plus 1. Now moving these curves 1 unit up is a task. So moving the horizontal line, the x-axis, down by 1 unit is much easier. And if you just remove this and write 0 here and 1 here, now this is tan theta plus 1, graph of tan theta plus 1, this right here. So for example, if I have a question 7 tan 3 theta minus 2, so what I'll do is, because it is all with pencil, I'll quickly mark these 4 points, draw these dotted lines vertical, draw this sketch. Now this 7 doesn't matter anything to me. This 3 means it ends at 120, and this minus 2 means this graph should move 2 units downwards, or I should move the horizontal line 2 units upwards and remove this previous line. But I do need these markings. This 120 should be right here above the previous one, and this point is 60. This vertical line was 30, the second vertical line was 90, and because it is minus 2, the graph is moving down. This is 0, this is minus 2, and that's complete. Any confusion till now?